So the video got cut off when we started 1D. I'm going to go back through 1D again, and then we're going to continue back through the rest of the worksheet. So what's happening here is we've got three separate things. We have the -1 out front, which indicates a reflection over the x-axis. So I'll put a bullet point here and say reflected over x-axis. We have the -1 within the absolute value bars, which we think of as our phase shift. A -1, we're actually going to the right 1 unit. And then we have the -3 on the outside. That's a translation of down 3. So always start out by graphing your initial parent function. And I'm going to break this up into 2 separate steps. So before I get to my red final line, I'm going to do the reflection. Once I have the reflection, I'm then going to do both translations in one step. So I've reflected this whole thing just across the x-axis. And then from here, I'm going to do my right 1, down 3. So I'm going to move to the right 1 and then down 3 points. To the right 1, down 3 points. For all of these, and then I've got a couple points plotted, and I know the general shape of the absolute value is not going to change because I don't have a dilation occurring. And so once I've gotten a couple points, I know the rest of the way that it's going to flow. And so in red here, this is my final piece after the reflection, the moving right, and the moving down. Okay, moving on to the back, we now have a new parent graph. F of x equals x squared. Our parent graph, this is a quadratic, and I didn't add on the first page, I didn't write absolute value. You can go back and add that. This one is a quadratic. I know the basic form of a quadratic if I start at the origin. If my f of x, if my x is 1, my f of x is 1, so 1 squared is 1. 2 squared is 4. And then I know the same thing for -1 squared is 1, -2 squared is 4. So we need to know these general points of our parent function because these points are going to be ones that we use when we are doing our reflections and our translations and all of those. So starting out, we see that we have a negative out front. This means it has been, in words, reflected over the x-axis. So reflected over the x-axis. So in green, I'm going to do that reflection. So my origin stays the same. Now I have 1, -1, and -1, -1. I have -2, -4, and 2, -4. So this, and still in a dotted line, it's not my final answer. This is my reflected parent function. And now I'm going to see, okay, well, I'm adding 3. So I'm going to move 3 units. So each of these green dots, I'm just going to slide up 3 units. So 1, 2, 3, 1, 2, 3, 3. This one moves up 3 as well. 1, 2, and 3. So from here, I'm going to just sketch in my shape. That is my final answer for this one. Okay, moving on to 2B. The only thing that's changed is we have a +1 within our parentheses. This is going to be like, again, I'm going to repeat this over and over again, our phase shift. We're moving to the left 1 unit. So starting with plotting the basic points of my parent function, we always want to start there. I'm going to then move each one of these to the left 1 unit. And then those get connected with a straight line for our final answer. Okay, 2C, we've got a few things going on. We have a dilation, a translation on the inside, so left and right, and something on the outside, up or down. So we'll start with the parent function, graphing that. So 1, 1, 2, 4, -1, 1, -2, 4. Okay, so let's start with our stretch. So I'll do 2 bullets because 2 things are happening here. So we're going to stretch. There should be a C, stretches away from the x-axis. Then we're going to move left 1 and then down 3. The 1 + 1, left 1, and then down 3. So I'll indicate my stretch first. So when I was at 1, 1, I'm now actually going to be at the rate of 1 with a 2. I'll be at 1, 2. Instead of being at 2, 4, I'm actually going to be at 2, 8. So we can't count all the way up to 8, but we can kind of plot it and assume where it's going to be. So 6, 7, 8, it's going to actually be kind of up here. Negative 1, 1 is going to become negative 1, 2. Negative 2, 4 will be negative 2, 8 as well, which is going to be kind of up here. So that is our stretch. They've just gone further away from the x-axis. A little bit challenging to see. Can't zoom in while I'm recording. Sorry about that. So now I'm going to do my translations all in one step. I'm going to take each of these points, move it to the left 1, and then down 3. So from here, move over 1, 1, 2, 3. From here, move over 1, 1, 2, 3. Over 1, 1, 2, 3. Move over 1, 1, 2, and 3. Move over 1, 1, 2, and 3. And then this is my final answer here. Okay. Last one for the quadratic parent graph. You can start out by just sketching that in really fast, remembering our key points. We have another dilation, but now it's 0.5, so we're going to sink closer. So sink closer to the x-axis, and we're going to move up 1. That plus 1 means an up 1. So in my green, I'm going to show the sinking upward, and I'm going to go ahead and add 1 to that all at one step. So if I've moved up 1, 1, we stay at this point. If I was at 0, 1, I'd be at 0, 1 half. Well, now I'm going to be at 0, 1 half, moved up 1 space. So I'm actually going to do this in all at once. Okay, if I was at negative 1, 1, sinking, I'd be at negative 1, 1 half. I'm sinking at a rate of 1 half. Well, if I was at 1 half, I'm going to move up 1. I'll be at 1 and a half. Here I was at 2, 4. My sinking, I would have been at 2, 2. Move that one up just 1 unit, I would be at 3. Same thing here, negative 2, 4, I would be at negative 2, 2 with the 1 half rate of sinking. Moving up 1, I'd be at negative 2, 3. And so this is what my graph looks like. All right, moving on to the parent graph, this is the square root. Square root, so if anything's under the square root, we think of that as our phase shift. If it's not under the square root, that's our vertical shift. Negative outside, that's a reflection. A coefficient out front, that is a dilation. So starting with the parent graph, what that looks like. 0, the square root of 0 is 0. At 1, the square root of 1 is 1. At 4, the square root of 4 is 2. So this is the general shape of our square root, and these are our 3 important points. We don't have anything down here in the negatives because the square root of a negative number, let's say the square root of negative 1, that's I. We don't have anything to plot for that. So we'll just use these 3 points as our main points of focus. From here, in words, I'm going to say, well, I'm moving to the right 4, minus 4 on the inside. So from this point, 1, 2, 3, 4. From this point, 1, 2, 3, 4. This point is off the graph. Well, I don't need it. I can just draw in that general shape of what it will look like. Okay, for B, same thing, the general shape, 0, 0, 1, 1, 4, 2. I have plus 3, so I'm going to move up 3. So each of these 3 points, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is my general shape. All right, we've got 2 more, and then we are done with these notes. We've got negative square root of x. This is a reflection, so it's being reflected over the x-axis. So my general shape, 1, 1, 4, 2, all of that. This just being reflected, 0, 0, 1, negative 1, and 4, negative 2. So all of these points just get pushed and reflected over the x-axis. As if you put a mirror in between, it would show equal on both sides. All right, finally we have a stretch away. It's a dilation. This stretches away from the x-axis, and thinking of it stretching away at a rate of 2. So our general 0, 0, 1, 1, 4, 2. So 0, 0, 0 times 2 is still 0, so we're still at the origin. 1, 1, 1 times 2 is 2, so now we're at 2. 4, 2, 2 times 2 is 4, so now we're at 4, 4. And here is our final answer for this one. It's been stretched away. All right, so we've gone through all of the notes. You do still have a packet of practice problems for these, so if you want to go through and work on those, that would be a great idea. I will be posting both keys to Blackboard. Let me know if you guys have any questions via email.